Lipids are the next macromolecule out of the group of four. And as you can see from this picture, this harbor seal is full of lipids. Lipids are macromolecules that we'll see have many different functions, but one of the big functions out of this group is energy storage, because one of the main macromolecules in the lipids section is an energy storing molecule. So we're going to take a look at these different lipids. Before we can take a look at the different groups, we need to talk about how these guys are linked together, because we're going to see they're very different as far as their characteristics and how they are going to function. So many of you, I'm sure, are familiar with how Italian dressing works, right? So if you have an Italian salad dressing bottle and you shake it and then let it sit, it separates into those two layers of oil and water, or as it says here on the slide, vinegar. That water layer is a mixture of water and vinegar. So why does it separate into those two layers after you shake it? You probably said something along the lines of water and oil don't mix. And the reason why is because the molecules themselves of oil and water are interacting with each other, or in this case, not interacting with each other. So it comes to these two terms right here, hydrophobic and hydrophilic. So hydro is referring to water, right? So if you're doing hydro powder, you're getting your electricity from water. Phobic, you're probably familiar with, means that you're afraid. So if you are hydrophobic, that means that you have a fear of water, right? So hydrophobic molecules are afraid of water, or in other words, won't mix with water. So those oil molecules are hydrophobic, which is why they separate. Anything that's hydrophilic loves water. That's what philic means. Philic means to like. And so hydrophilic molecules are things that are going to dissolve in water. So they are things that are polar. So in the water lecture, we talked about polar molecules having charges. So anything that has a charge is going to be hydrophilic. So vinegar contains acids which have a charge. They are positively charged. So also things like salts and sugars, they all have charges on them, so they're going to dissolve in water. So how is this related to lipids? Well, the lipid features are that they are non-polar molecules that do not dissolve in water, aka they're hydrophobic. That's why they don't dissolve in water. They are non-polar. They have no charge, and so therefore they don't play well with water. They feel greasy to the touch. This is because of that non-polar characteristic. And they can be a good source of energy storage. And I mentioned that one of the groups is a well-known one, that is the fats. So we're going to look at three groups. There's actually a few more types of lipids, but these are the three main ones that we're going to run into in this text. So we've got the fats, and we're going to take a look at a couple of different types of fats. These are the long-term energy storage, an insulator type of lipids. So again, we see another cold area organism, this time a penguin, and they are using fats for their long-term energy storage, but also insulation. It works really good as a insulator to keep you warm. We're going to look at the sterols. You may have heard of these, called natural steroids. So these are going to be things that are regulating growth and development. And then we're going to look at the phospholipids briefly. These are the guys that are making cell membranes. We'll actually see these again in chapter 4. So if you are going to, actually, we're going to skip that question. So fats, we're going to start with those guys. So fats are very tasty molecules. In fact, we like fats better than sugar. We'll talk about why. Another name for fats is triglycerides. And let's take a look real quickly as to why. So fats are made up of 2 parts. Fats are not polymers. They're not made out of a bunch of small units like starch or cellulose in the carbohydrates. All fats are structured the same way. So they are made out of this section that we call the head, which is a glycerol. And so the glycerol is where the glyceride comes from. And the tri comes from these tails that are attached to it. And the tails are fatty acids. And if you look, they are made up of carbons and hydrogens that are hooked together, big long tails of these. And remember, carbon and hydrogen bonds are where the energy is stored at. And so this is why fats work really well for long-term energy storage, because there's tons of carbon and hydrogen bonds here. You'll notice too that the lipids, like the fats, are mainly made out of carbon, hydrogen, and oxygen. Again, big reason why your body is made mainly out of these 3 elements along with nitrogen. Whenever we see a fat in the text, it's going to look like the little 3-legged stool down here. We'll see sometimes the legs are bent, and we'll talk about why. I just want to make sure, yep, that's everything on that one. All right, so let's talk about why we like fats. So fats are good for that stored energy because they contain more energy. In fact, we prefer fats over sugars because they contain so much more energy. If I were to offer you, and this is going to sound really gross, but if I was to offer you a cup of sugar and a cup of bacon fat, now I know that you probably aren't going to eat either of them, but that cup of sugar versus the cup of bacon fat, the bacon fat is going to have over twice the amount of energy in it that the cup of sugar will. And so this is why we have developed and evolved a very strong taste preference for fatty foods. So let's think about this for a second. In the question, what is your favorite food? So think about your favorite food. My guess is whatever your favorite food is, it contains some sort of fat. So if I was to be able to have whatever I wanted right now, it would be an elephant ear, a Dumbo ear from the fair, one of those big deep fried dough pieces that they cover in sugar. So it's got sugar in it, but the main reason why I love it is because it's deep fried in oil, and it's got the extra butter in it in the dough to make it nice and crispy. And so a lot of what I'm sure you guys put down contains high amounts of fat. So there are 2 types of fat. We've got, and I'm sure you've seen these on labels, saturated fats and unsaturated fats. So we're going to take a quick look at how these are different and why we need to know about them. So if we look first at the saturated fats, you'll notice over here, we've got back in the back, this is ice cream. We've got eggs, butter, cheese, cottage cheese. I think this is milk in the back. I'm not quite sure. So all of these items in this picture contain saturated fats. Other things that should be here too would be things like bacon fat, bacon grease, any meat that you would cook, like if you cook a steak and let it cool down, you get that nice layer of fat in the pan. Those are all saturated fats. And if we look at the molecules up close, this is what they look like. The fatty acid chains are straight. And that's because every carbon in those tails has 2 hydrogen atoms on each side. and then they're attached to carbons on the other side to make their 4 bonds. So it makes the chains very straight. So when you get a bunch of these saturated fats together, they can pack really tightly because those chains squish really closely together, right? Think about, like, okay, before COVID, people at a concert, right? You could pack lots of people really tight in if everybody, kept their arms to themselves, right? So saturated fats have these straight fatty acid chains that allow them to pack really tight together. And you might be thinking, yeah, but so what? Well, this is why, if you think about all of these foods, they are generally going to be solid at room temperature. Now, there's some exceptions, like, the ice cream. Well, yeah, the ice cream isn't going to be, but the fat parts that are in the ice cream will be solid. But all of these other guys are going to be solid at room temperature. Think about, again, like the bacon fat and steak fat and so forth. That's different than the unsaturated fats. So unsaturated fats, you can see their legs aren't straight. They're bent. Why are they bent? That's because some of the carbons, instead of having all of the bonds between carbons and hydrogens as single bonds, some of the carbons have double bonded between carbons. And so you're missing hydrogens out here. And so at least one carbon in the hydrocarbon chain, the tail, is bonded to another one with a double bond. And every time that happens, you get a bend in the tail. And so here's where there's a double bond. There'd be a double bond here and here and here. Okay. And so every time you get a double bond, you get a bend. And these guys are going to be nearly impossible to pack tightly together. Again, think about like those people at the concert. Now everybody wants their personal space. It's getting really hot and so forth. And so everybody's going to start putting their elbows out to get people to back off. And so that's what unsaturated fats are doing. They've got kinks, bends in their tails, and so they can't squish together. If you look, there's the same number of fats in these two pictures, but these guys are going to take up a lot more space. And because of that, unsaturated fats are going to be liquid at room temperature. So, any guess what the name of an unsaturated fat might be? And I'll give you a hint. One of them comes from what's in the picture up here. I don't know how good of a hint that is. Oils. So unsaturated fats, their other name is oil. All right, so you can have vegetable oil, in this case fish oil, trying to think, olive oil, peanut oil, coconut oil. What are you noticing about most of these oils? They come from plants, right? So mainly saturated fats are going to be solid at room temperature because of the straight chains, and they come mainly from animals, if you look at the products here. And unsaturated fats, liquid at room temperature because of the bends in the chains, and they're mainly going to come from plants. Even though we got a picture of a fish in here, the fish oil is one of the exceptions. Almost all other oils are going to come from plants. So, I'm going to skip that because I'm going to tell you about trans fats. So if you look at a snack food package, they're going to often say that they contain partially hydrogenated vegetable oils. And if you have a snack food pack like chips or cookies or anything like that around, I recommend that you go and find it and see if it says that on the package. And what does that mean? What does it mean to partially hydrogenate a vegetable oil? We're going to take a look. Because if you add hydrogen atoms to a vegetable oil, it's going to change how that oil tastes and how it reacts in that food. And so that brings us to what are trans fats. So trans fats are a result of putting in hydrogen atoms to those oils. And so that's why it's partially hydrogenated vegetable oil or soybean oil or whatever it is. So what we do is using different chemical reactions, usually involving heat, we're going to force hydrogens in here, and it's going to unbend the kink, right? So hydrogenation is going to straighten out the hydrocarbon tail. So unsaturated fatty acids are called the cis form, and once it's been partially hydrogenated, so some of the double bonds remain, but not all. So you can see one's here, but the other two get replaced because those hydrogens get forced in. So this is partially hydrogenated, and that's now the trans form. So it's been transformed basically into a different version of that fatty acid on that oil. Now you'll see that it's the less healthful trans orientation. And the reason for that is when an unsaturated fatty acid is in this cis form, they can't pack closely together. That makes them liquid at room temperature, but they also can't pack closely together, and that keeps them from packing closely together in things like our blood vessels. And so saturated fats are actually the one that is tied to problems like heart disease and so forth, because they can pack closely together with other molecules and block arteries. Unsaturated fats, on the other hand, because they have those bends, don't pack closely together, and so they don't get stuck into the arteries. These trans forms, they are going to act more like saturated fats because the tails are straighter, and so they can act like a saturated fat, which is why we started making them, because not only do they act like a saturated fat, that's why they're less healthy, because they can lead to that heart disease, but they also taste like a saturated fat. And so our brain likes the taste of this form, the trans form, better than the cis form. And so we've been using partially hydrogenated oils to add to our snack foods and so forth, because it can improve food's taste and texture, because it'll act more like a saturated fat, but it'll also increase the shelf life. And so that's why you find it in things like, snack cakes and chips and things like that. Most areas now you cannot get trans fats in your food, or they're very, very low, because we now know that they are unhealthy.